Okay, let's look at the properties of definite integrals, right? Some of them are very similar to the properties of indefinite integrals, right? But the first one, right? So you have an integral from a to a of f of x dx, right? So you can think of in terms of area. So this is an area of the region with no width, because you're starting from A and ending at A. So that whenever you have that, then the definite integral is going to have a value of 0, right? When you switch lower limit and the upper limit, then what happens is it changes sign. So it's a negative integral from A to B, f of x dx, right? And when you have a constant multiple, just like the indefinite integral, we can kick the constant outside of the integral. So what you get is k times, so constant is outside, then you do an integral from a to b, f of x dx, right? And if you have addition and subtraction, we can evaluate the definite integral of each function, then do the addition and subtraction later. So we do the definite integral of f of x and the definite integral of g of x. Then if it's addition, you do the addition later, or if it's a subtraction, do the subtraction later. All right. And another thing is that if you have an integral from a to b, you can actually kind of take a break. So say a to say somewhere between c and f of x dx. Then you can kind of start back up again from c and finish it to all the way to b. So f of x dx. All right. So let's look at some concrete example here. So if you, let's say these three values are given. So definite integral from 1 to 4 of x is 7.5. And the definite integral from 1 to 4 of x squared is 21. And the definite integral from 4 to 5 of x squared is 61 over 3. Right? So let's say those three values are given. All right, then let's try to evaluate these integrals. All right, this one. All right, pay attention to the lower limit and the upper limit. They're the same, so we don't really care what's inside. It's going to be 0. Right, so I'm using property number 1. All right, so this one, since you have addition, we can split into two integrals. So this is going to be integral. So 1 to 4, all right, dx, and plus another integral from 1 to 4 dx. All right, then another thing we can do is that here 2 is a constant, so a constant multiple, so you can kick that outside. So you can have 2 here, then you have x, right? And same way, if you have 1 over 7, you can kick that outside. So it's going to be 1 over 7 outside. Then you have x squared, right? And this can be, let's see, we know that this value is given to be 7.5. So it's a 2 times 7.5 plus 1 over 7 times this value is given to be 21, right, which is going to be 7.5 times 2 is 15, and 21 over 7 is 3, so it's a 15 plus 3, so answer is 18, right? We can get that. How about the part C, right? So it's going from 5 to 1. Maybe we should rewrite it from 1 to 5. In order to do that, we have to put the negative sign in front. So 1 to 5, right, x squared dx, right? But you can see that none of them actually going from 1 to 5. So what we can do is we can actually split that in two. All right, so negative sign is still there. Then you have integral. How about going from 1 to 4 of x squared dx? Then we can finish it up from 4 to 5 x squared dx, right? So we can do that. So that's going to give you, right, so negative sign is still there. So 1 to 4, so that's going to be 21, right? And plus 4 to 5 is 61 over 3. So plus 61 over 3, right? So this is going to be, right, so 21 is 63 over 3. So it's going to be 124 over 3 with a negative sign, right? So that's going to be the value of this integral. All right, that's it. I hope that this was clear. All right.